Good morning children, we will start a new lesson, that is Triangles Session 1. So we completed Euclid's geometry in our previous session where we understood the concepts of Euclid's axioms and postulate where the whole geometry is based on. So let's study a new chapter here, triangles, and where we understand the congruence of triangles here. Before that, let's first understand what do you mean by congruent figures. Two figures are said to be congruent if they are of same shape and size. That is, two circles are congruent if they have same radii. Two squares are congruent if the measure of the side is same. Two triangles are congruent if they have same sides and angles equal there, right? Because squares, we all know that all angles are equal to 90. So that means when we talk about triangles, there should be some criteria for that. What do you mean by it? Congruency of triangles. Two triangles are congruent if the sides and angles of a triangle are equal to the corresponding sides and angles of the other triangle. That means when we talk about congruency, we always compare that with another figure, right? Now, apart from, see, there is always a confusion, congruent figures and similar figures. I can tell that two squares are similar, but if two squares have to be congruent, then their side measure also has to be same. Just look at this. This is a square which is similar to the another square. Why? Because a square, all the angles are 90. Similarly here, they are similar. We call them similar, but we can't call them congruent. When can you call them congruent? You can call them congruent only if the measure of this side is equal to measure of this side, right? Only then we call them as a congruent figure, otherwise they become a similar figure. So in your standard 9th, we study about congruency, that is we talk about whose sides and angles are equal, corresponding, and in your standard 10th, we learn about similarity, okay? So, two triangles are congruent if their corresponding sides and angles are equal to each other. So, in congruent triangles, once they are congruent, we say that the corresponding parts of the congruent triangles are equal, which we call that as a CPCT, corresponding parts of congruent triangle. Suppose if I have two triangles ABC and PQR, and if I talk about the angles part, angle P is equal to angle A, angle Q is equal to angle P, angle R is equal to angle C, and PQ is equal to AB, QR is equal to BC, and RP is equal to CD, right? That means triangle PQR, this is simple children, equal and congruent. Triangle, these two are equal and congruent to triangle ABC. So when two figures are congruent, their corresponding sides are and angles are equal. All corresponding parts are equal, which we call that as CPCT. Now, on what criteria are this congruency based? Is it based on side? Is it based on angles? Or it is based on the combination with sides and angles? Let us just understand congruence or criteria for congruence of triangles. So, these are the criteria for congruence of triangles. The first criteria is side angle side. Now, just try to recall when we tried to construct a triangle, right? What are the parameters required to construct a triangle? Let's keep this aside. So, if I have to construct a triangle, I can construct the triangle provided that I have three sides. I can construct it. Provided that I have two sides and an angle given, I can construct it. Provided that I have two angles or I have one side and two angles, I can construct a triangle, right? Provided that I have only three angles, can I construct a triangle? So, no. You can tell, yes teacher, we can construct it. I said, okay, if you can construct it, then the triangle of, what will you take as a base, right? So, you will take the base as 5, somebody else will take a base as 10, 6. There is no correct thing what everybody can construct. But, when you construct a triangle based on three sides, everybody's will be the congruent figure, I can tell. Everybody have a correct base, sides, angles based even on this, right? That means to construct a triangle, what criteria or what thing we require here is at least one side must be there, right? So that is about the rules or the criteria for congruency of triangles. What about this? What about triple A? Can't we construct a triangle? No. Triple A will not come for the criteria for congruency, but triple A will come for the criteria of similarity. Right? That is what you study in 10th standard. You study in 10th standard about similarity of a triangle, where triple A becomes the criteria. In standard 9, you study the criteria for congruency, where at least one side is must and should, which is required. So based on these criteria, let us understand how do we prove the congruencies here. So the first criteria is SAS, which is called as side angle side. Side angle side congruence rule. Two triangles are congruent if two sides and the included angle. I have underlined their included angle. I'll tell you why. Two triangles are congruent if two sides and the included angle of a triangle are equal to the two sides and the included angle of the other triangle. Then we say that the triangles are congruent by side SAS. How is it? Suppose these are the two triangles. So side AB is equal to side PQ, side AC is equal to side PR. Angle A is equal to angle P. Is angle A the included angle of this triangle? Included means the angle which lies between two sides. Is this angle A lying between these two sides? Yes. Is this P lying between these two sides? Yes. That is the condition for SAS. Only then it is done by SAS. Suppose if I tell you children, this is a triangle, these two triangles, these are the two sides which are equal for these two triangles and this angle is equal. Is that also SAS? No. This is not SAS. Why it is not SAS? Because that does not have included angle. It is very important to see that included angle. Only for SAS we see included angle. Is that very clear? We'll move to the next one. Angle side angle. Congruence rule. Two triangles are congruent if any two angles and a side, any two angles and one side of a triangle are equal to the two angles and a side of other triangle. Then they are said to be congruent by angle side angle congruence rule. Now the thing is, in your book, in some other book, what they have also given, I will tell you that. So no more confusions to be created. In some books they have given, including your textbook, they have given two triangles are congruent if any two angles and the included side is equal. They have given. So according to them, they mean that it should be done. That is, included side means what now? Side should be included between two angles. Okay. But the condition here is, it is not compulsory. The side can be between two angles also, it is okay. Even if it is not between the angles also, it is okay. Okay. So that condition we can just vary here and there. But here there is no adjustment done, children. So though it is given in your book like that, we can understand this postulate in two ways. That is, any two angles and a side. If they are equal of one triangle and matching with other triangle, then they are congruent by ASA. Let's see the rule here. These are the two triangles given. So here I have taken it as an included side. Side between two angles. A is equal to P, B is equal to Q, AB is equal to PQ, equal and congruent by ASA. One condition. Or this is another triangle condition. This angle is equal to this angle is equal to this, written here. Some other side is equal, not included side, right? This is equal to this side. Therefore, how do we write for this congruency? It is equal and congruent by, read, angle side. AAS congruence rule. So, for ASA, it is also as included side or any other side. So, So there is no like a definite condition that it has to be an included side only. So don't get confused with what is given in the book. The main concept is there is nothing called two conditions can be given. But when you try proving a particular triangle by this condition, it has to be mentioned as ASA. If you are proving a triangle in this condition, it has to be written as AAS. After writing this condition, if you write AAS, the whole thing is done. Write what condition you have put it here. I hope it's very clear. Two more criteria we have, that is triple S, that is side, 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 and RHS, that is right angle, side, and right angle, one angle, side, and a hypotenuse. So the last two criteria for congruency, that is triple S, SSS congruence rule. If three sides of one triangle are equal to the another three sides of other triangle, then two triangles are said to be congruent by SSS congruence rule. Very simple, three sides where you have to prove. In triangle PQR and ABC, PQ is equal to AB, QR is equal to BC, and PR is equal to AC. Then triangle PQR is equal and congruent to triangle ABC by triple S congruence rule. And the last one, which is RHS, which stands for one right angle, hypotenuse, and any side. That means if it is a hypotenuse, a triangle will have two more sides, any one side. Congruence rule. If in two right triangles or right angled triangles, that is more important. We just cannot tell in any two triangles. If in two right angled triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then two triangles are congruent by RHS congruence rule. So let's consider two triangles ABC and PQR, where angle B is equal to angle Q, which is 90 degree. AC is equal to PR, which is hypotenuse, and any one side, children, can be BC or it can be AB, right? So BC is equal to QR. So triangle ABC is equal and congruent to triangle PQR by RHS congruence rule. That means now we are going to use these criteria to solve the sums. Rather, we can call them as riders, because these are the sums based on theorems or criteria. We have a theorem on SAS postulate, which we will be doing that in our next class. So this is about criteria for congruency of triangles, which is very, very important. In today's session, it's a very small session what I will be sending today, but you need to understand the concept thoroughly. What is ASA or AAS, what is SAS, what is triple S, and what is RHS. Because until you understand these concepts or congruency criteria clearly, you cannot be solving the riders given in the exercises. So first of all, perfect this, understand this, work out with some worked examples or see in that how the congruency is applied. It will be very easy to solve the exercise. So with this, we'll wind up this class today. Thank you.